Hey everyone, and welcome to the GKX. The term black hole was coined by physicist John Archibald Wheeler in 1967. Before that, these mysterious objects were often referred to as frozen stars or collapsars. Wheeler popularized the term because it succinctly captures some key characteristics of these objects. Black refers to the idea that nothing, not even light, can escape the gravitational pull of a black hole once it crosses a region called the event horizon. The event horizon is the boundary beyond which the escape velocity exceeds the speed of light, making it impossible for anything, including light, to break free from the gravitational grip of the black hole. The term hole suggests an empty space or void. In the case of a black hole, it refers to the region where matter has collapsed to an extremely high density, creating a gravitational field so intense that nothing can escape its pull.
Is gravity really the strongest force? Hold your horses. While gravity gets praised for holding planets together, the strong nuclear force reigns supreme at the atomic level. You think gravity's the champ? Think again. It's like a microscopic sumo wrestler, keeping protons and neutrons locked in a tight hug inside the nucleus. Strong force, tiny but mighty. But don't count out the electromagnetic force just yet. This electrical prankster controls everything from magnets to light and even makes atoms stick together. It's like the universe's invisible glue. So, while gravity might not win every arm wrestle, its reach and additivity make it the ultimate master of the universe on large scales. Remember, science is full of surprises.
Remember Pluto? Used to be the 9th planet, chilling with the big boys. But then, bam! Demotion to dwarf planet. Harsh. So, what happened? Did Pluto mess up? Did Jupiter steal its crown? Nope. It's all about science and, well, rules. The International Astronomical Union, IAU, decided to be strict and made a new definition for planets. Pluto checks 2 boxes, round and sun orbiting. But here's the kicker, the neighborhood clearing part. Pluto shares its space with a bunch of other icy rocks in the Kuiper belt. Not exactly dominating the scene. So, Pluto got downgraded to dwarf planet, joining cool cosmic comrades like Eris and Ceres. Don't feel bad, Pluto. You're still fascinating, mysterious, and full of surprises. Plus, dwarf planets are a whole new club to explore. Ever dreamed of getting caught in a diamond shower? Forget Paris, Neptune is where it's at. That's right. Neptune. The furthest planet from the Sun isn't just icy, it's literally raining diamonds. But how, and why? Deep beneath those turquoise clouds, things get crazy intense. Millions of times the pressure on Earth, hot as heck, and swirling with methane. That smelly gas on cow farms, but much colder. This methane gets squished so hard, carbon atoms pop out and say, let's make diamonds. Boom! Diamond rain is born. But these aren't the fancy gems you see in rings, they're more like giant hailstones. Diamond rain isn't just cool, it tells us about Neptune's history. These diamonds sink towards the core, leaving clues about the planet's formation. Plus, it might rain on Uranus too. Double diamond bonanza. So, next time you gaze at the stars, remember, that distant blue dot might be raining the blingiest stuff in the universe. Hey, everyone! Welcome back to GeekX. We are diving into the intriguing world of astrophysics to unravel the mystery behind one of the most enigmatic objects in the universe, neutron stars. During this epic explosion, the outer layers get blasted away, while the core gets squeezed under unimaginable pressure. This pressure is so intense that it crushes atoms, fusing protons and electrons into, you guessed it, neutrons. Now, picture a sea of neutrons crammed together like sardines in a can. That's basically what a neutron star is. The distance between these neutrons is like comparing a pea to a football field. But wait, there's more. This neutron soup isn't just sitting there. It's actually pushing back against gravity with a force called neutron degeneracy pressure. It's like a cosmic game of tug-of-war, where gravity tries to crush the star further, and the neutrons resist with all their might. Today, we're diving into the mind-bending case of Saturn's disappearing rings. Did you know, Saturn's iconic rings aren't permanent fixtures? Every 13 to 16 years, they seemingly vanish from our view. But don't panic, it's not a case of aliens stealing them. It's all about celestial choreography. Saturn, like a majestic dancer, tilts on its axis. As it orbits the Sun, its tilt changes, and sometimes, we get a face-on view of the rings. But when the tilt reaches a certain point, we see them edge on, making them incredibly thin and practically invisible from Earth. These collisions, along with Saturn's powerful gravity, are slowly pulling the ring material inwards. Some scientists estimate that the rings could completely disappear in as little as 100 million years. While the future of Saturn's rings might be uncertain, there's no need to mourn just yet. We still have plenty of time to marvel at their beauty and unravel their secrets. Hey everyone, and welcome back to the channel. Today, we're gazing into the cosmos and asking a question that's as old as time itself. Why do stars die? These celestial beacons may seem eternal, but just like everything else in the universe, they have a lifespan. And their demise plays a crucial role in the cosmic game of life and death. Stars, at their core, are giant nuclear furnaces. They fuse hydrogen atoms into helium, releasing unimaginable amounts of energy that make them shine and counteract the crushing force of gravity. But this process isn't infinite. Over billions of years, stars slowly burn through their hydrogen fuel, like a candle nearing the end of its wick. The way stars die, however, depends on their size. Smaller stars, like our Sun, take things slow. As their hydrogen runs low, they swell into red giants, fusing helium briefly before shedding their outer layers as planetary nebulae. The remaining core shrinks into a dense white dwarf, slowly fading into oblivion.